Ladies and gentlemen, good to have you back for the presentation of our partner country here at the AM4U stage. We had already some exciting presentation. We're heading over to the next topic, and this is super interesting because at Additive Manufacturing, we are always looking at the industrial users of additive. We have three exciting speakers about the topic, return of experience of real industrial AM users, and I'm happy to welcome here on stage Arnaud Cosson. I hope I put the name correctly. It's not that easy for me.
That's it.
Thank you so much. You are digital workflow engineer at Decathlon. Then we have Mélanie Chevé.
Hi.
Good to have you. Additive Manufacturing project manager at one of my favorite companies, Renault. Great to have you here. And we have Florent, Lebrun, antenna department, technology innovation at Thales Alenia Space. Great to have you. Arnaud, do you want to kick off?
Yes.
Thank you so
sure.
much. Stage is yours. Please come over here.
Okay. It's not the right slide?
I hope so.
Okay.
Is it not yours?
It's not mine.
It's not yours. Okay. See.
Maybe next one?
Something.
Okay.
So we are live. So probably, Arnaud, if you don't mind, you can already start.
Okay. I have very, very good pictures to show, so that's...
And I'm pretty sure that Anya is already on her way in order to check that for you.
Okay.
And you will get, of course, an extra minute.
Okay.
Thank you.
Yeah, so just I want to show you some use case we did with Decathlon. So I'm part of the team which is called Additive Takeoff, which is a dedicated team to additive manufacturing. And here it's just focused on real case of production. So the first one, you can see here, it's a nose clip. So this is the first fully 3D printed product that was available in store, in a Decathlon store. This nose clip is a single body design product, no assembly, and made in France. We sold around 2,000 of it. And the product is no more available in store because the user satisfaction was under 3 on 5, and because the design was not well adapted to every nose morphology, so it was removed. But thanks to the low investments, because we have no mold, no tooling, thanks to additive manufacturing, we had the opportunity to fail without, and so to learn with a low impact. The second use case, it's really worse without the picture.
I check for you quickly.
The second example is a very good example of how additive manufacturing can help to improve products after their release. On our electrical bike, when you remove your battery, the connector, the plugs, they are visible. And so if it rains, the rain can come into the connector, and so it's not good for the lifetime of the battery. So we made a small cap, and this product is available for 10 euros on the Decathlon website. We manufacture it on demand, and we made 150 of it this year.
Arnaud, just to inform you quickly, we unfortunately do not have a presentation. So for whatever reason, wasn't sent. But this shouldn't hinder us from exploring Decathlon. And probably you describe it as best as you can, because it's already exciting. And I'm very sorry for that, but unfortunately there is no presentation.
So I will focus on other topics that have that don't need the...
Just a quick side remark from my side, not to interrupting you, but as you all know, you have probably the products on your booth and can show them. Do you have a booth here?
No, we don't have a booth, but I have pictures there. So if you want, if you're interested, come to me.
But they're still working on that, and I promise you, once we have that, we do an extra round, and you can show the pictures.
And also,
quickly.
all this example, except the first one, which was removed from store, they are real life, so they come. They come from. You can see them in stores. Oh.
Here we are. It's coming slowly.
Coming soon, maybe.
And here we are.
Okay, great. So this was the nose clip.
Awesome.
This is the battery cover. I will skip this one because of the time. This one is a OEM component, which is part of the crankset of our mountain bikes. And with it, the integration of electrical shifter is perfect. So we have produced a third batch of 1,000 for that part. This one is really interesting. The story of this combo lock is amazing. the production of the bike was stopped because two components were not compatible with each other. So we had 3 weeks to find a solution and resume the production. Combining the works of the bike engineers and the power of Adlab Takeoff team, we have been able to produce in-house 3,000 parts in less than 2 weeks and resume the production. This part is now a new standard that leads to a better components compatibility, so we have a wider diversity of components that we can use. And we have produced 2,500 more of this year. Another production story where AM saved us from a difficult time. 6,000 bikes to be produced, 15 weeks delay for the mold, and a project team came to us for a rescue. So within 2 weeks, we develop, we adapt manufacturing recipe, and we validate this part. And the next 2 weeks, this TPU part was manufactured by our partner AirPro, and to be delivered to our factory in Portugal. And of course, the cost of the part was higher than the original one that should be produced with injection, but it was offset by the cost we avoid by the immobilization of the production. So all these examples, they show in many cases, additive manufacturing is the best option for components and end products. And these use cases are some of the many stories we are writing in Decathlon with additive manufacturing. And we are confident that there is much more to come in the future. Thank you.
Arnaud, I know I'm not allowed to ask a question, but I'll do it anyway. Just one, because it's super interesting. If we see this product, for example, has it the same, let's say, material specs in terms of durability and quality, so that they could rely on your solution?
Yeah, exactly. Every component or every product we made with additive manufacturing, they follow the same quality acceptance rule, the same lab test than other manufacturing technologies. So yeah, that's really the quality is really the same. And just a fun fact, because I focus here on the production series, but we also work a lot on spare parts. So some of our spare parts, they are available on the Decathlon website. So the user, the customer, they can order directly from the Decathlon website. And one of these parts, the number of cycle the part is okay, is better than the original one.
Awesome.
So
awesome.
In some cases, additive manufacturing leads to better results than original manufacturing technologies.
And honestly, Arnaud, these are exactly the examples we need to push additive manufacturing forward. I was anyway a fan of Decathlon. I'm a heavy buyer, but even more after your presentation. Thank you so much, Arnaud.
Thank you.
Thank you for the presentation. Applause for Arnaud, please. Yeah, from Decathlon to Renault, Mélanie, stage is yours. Let us see what you have brought us.
Hello. So, Mélanie Chevé, I work as additive manufacturing project manager at Renault Engineering Process in a techno center in Guyancourt. And I will present to you briefly our additive manufacturing journey with the first video. That is a hint to start the video. Thank you. So we have been using additive manufacturing from prototyping to tooling and now in our vehicle serial parts. First, about prototyping, it's a skill and know-how we have been developing for more than 20 years. So we have prototype centers that work with many different technologies to accelerate the validation and development phases of our vehicles. In all of our plants and manufacturing sites, we have also developed additive manufacturing printers and skills to be able to produce locally, reducing storage and cost of spare parts and tooling as a great factor for enhancement of the performance. And today, we also print parts in our vehicles. Here you have an example for our professional driver in Limo Mobilize. And if you buy your Alpine, A110 R or A110 Eternity, it will integrate printed parts in Florent refactory and assembled in our Dieppe factory. If you also use ZT car sharing, you will find different printed components, such as the key. So the message is that we are developing the technology internally with partners for needs and external needs also.
Thank you so much.
I will also present in a second video one of the tools that has allowed us to integrate the parts in our vehicle. It's our Flin refactory. It's a global project in our historical plant of Flin to transform our industry focused on circular economy. For the circular economy of electric battery and vehicle, and it integrates an additive manufacturing center equipped with different technologies for our internal needs of prototype, toolings, and vehicle parts, and also for external needs who wants to benefit from our skill and industrial know-how. This, for us, is a key transformation for the French territory, for our historic plant, to focus on high-value parts, for high-value projects with key skills to develop in France for Industry 4.0, with skills such as modeling, new processes, validation for industry of automotive and other French industries. If you want any further information about the refactory or how we use 3D printing at Renault, don't hesitate to contact me.
Thank you, Mélanie. Great, awesome. I unfortunately can't afford an Alpine, I guess, but it's great to see that's already in a car, even in a serious situation.
Yes.
But how many of these Alpines are produced already?
Today, it's 1,000 vehicles equipped with those printed parts. And main reasons to choose additive manufacturing for this vehicle is the time to market. Compared to injection molding, we saved approximately 8 weeks in our planning, and we were able to solve very fast problems and integrate it in our limited series.
Again, great to see that you are really pushing forward the AM industry with real-life products and not only prototypes. Thank you so much for being our guest. So finally, Florent, it's your part, and I'm really excited to see what he brought us. Thank you.
Thank you. Good afternoon, everybody. The presentation, perhaps. It's coming soon, perhaps.
It's a hope.
Okay, thanks to offer us the opportunity to share with you what we do with additive manufacturing on Thales Alenia space. I will speak only about telecommunication satellite application. My name is Florent Lebrun. I'm based in Toulouse, in France, and I'm in the antenna department of Thales Alenia space. I will speak only about selective laser melting technical solution we use today for many flight applications. We have started using this technology in 2015. We produce about 500 parts each year for flight application with several partners, and we now have in orbit more than 1,800 parts. We produce all our parts with different partners, so we have our own production capacity based in Morocco with several metallic printers to produce titanium and aluminum parts. And we also work with external partners, French partners like Lazy, Additive 3D System also in Belgium, and 3D metal print for prototyping activities. All these partners offer complementary production capacity and technology. Just let me provide you, share with you different applications we have on our satellite. So on our telecommunication satellite, we use this technology to produce many inserts, titanium inserts for composite applications, many brackets, titanium brackets. Titanium is really very helpful for stability, thermoelastic stability. We produce big parts also with Lazy, for example, on their X-line in aluminum for inertia wheel frame, for instance. Also some antenna supports, and we also produce with other partners some waveguides application for RF application. We can also mention titanium brackets for propulsion subsystem named ETHM. We also, in Thales, have a new platform currently in development to offer more mission flexibility to our customer. And on these platforms, it's interesting to note that we have increased the number of 3D printed parts. We can focus on RF application. On this platform, we will print more than 150 3D printed feeds, which is really good for us. A really step in terms of serial productions. We'll produce also many brackets for reflectors and some RF application in terms of waveguides also, which the design is driven by our colleague from Thales Avionics. And we also have printed, yes, a big horn with the big printer of 3D systems, the Factory 500, a very promising application for us. In terms of R&D activities, just a macroscopic vision of what we do today. So we focus on RF applications. We also have many applications in terms of thermal applications. We try to introduce heat pipes, thermal loops, also oscillating heat pipes. And in terms of mechanical application, we also try to improve the performance of our fittings, considering hollow design on organic shape, and introduce also functional lattice. What we can say also is that we try to take more benefit from additive manufacturing, consider more multifunction parts. It's very important, especially because SLM remains a costly technology. In our business, we also have many unit production parts, and so it's also important for us to improve our capacity to obtain parts right for the first time. And so in this way, use distortion prediction software and warping compensation software. So, okay, it's time. Last word would be that this technology really makes the jump for our business. There is many new interesting technology on this Formnext, 3D printing of PCB, 3D printing of ceramics, and so for us, future in this way is very promising and for sure very exciting.
Great, thank you so much. Thank you so much. Big applause. Finally, as a summary, I can say it was very good to have you here because we discussed yesterday that especially for startups, for technology producer, it's very important to see the applications from the industry because that is what they got to have heading for. So thank you so much. Having you here was great. Good luck with the fair so far and keep on going. Okay, thank you so much. See you soon. Yeah, ladies and gentlemen, yeah, big applause for the audience. Thank you. So we just have seen some industry cases, and of course we need to see what kind of materials you need to use to create these industry cases. But before we step into that topic, you will get a 4-minute highlight break, and I'm happy to see you after that 4 minutes again here on stage. Enjoy the break.